Hi everyone, my name is Juan López Salazar. I'm part of the School of Basic Science, Technology and Engineering at Universidad Nacional Abierta, Distancia, and today we'll be solving task 2 of the Videogames optimization course. And in this video I'm going to show a performance of an analysis of a Unity video game using the tool Profiler. The goal is to identify some performance issues, explaining what those metrics mean in the program of Unity, propose solutions to optimize this project. So the video game testing is a first-person shooter, and we're gonna see what performance issues this small video game have inside of this program called Unity. So let's get started. Now we can see the metric here, and here we see the CPU usage graph. The average remains stable at around 4 milliseconds per frame, which translates to about like 250 FPS. That's really stable, but spikes also appear a couple of times, and these spikes are usually due to the garbage collector, which means this garbage collector cleans up memory used by temporary objects or to scripts that execute heavy tasks all at once. When we use new or concatenate strings in the update method, we are creating temporary objects every frame, which cause the garbage collector to activate frequently. So the solution is to apply object pooling, which means reuniting objects instead of constantly creating and destroying them. This reduces the memory pressure and prevents micro crash in the games, or stuttering or low performance. So if we see here, we have the rendering and draw calls. In this rendering section, we see that the batch strangles and vertices remain low, indicating that the GPU is not overloaded in this project. However, it's important to understand the concept of a draw call. I'm going to explain it a little bit. And it's each drawing command sent to the GPU represents extra work. So if we have dozens of different objects, the GPU will have to process them one by one. Okay, so to optimize this, we can use techniques such as static and dynamic batching, which group objects into a single call, or GPU instancing, which allows drawing multiple copies of the same object at once. Additionally, techniques such as occlusion calling avoid rendering objects that are not on screen. So an LOD groups displays simple models when they are far away, saving a lot of resources. That helps the GPU a lot. So we're gonna see here this other metric is physics and fixed update. In this physics section, we see intermittent activity, although it's not very high, if you can see here, but it can become a problem in large projects. So physics in Unity is calculated in a cycle called fixed update, and if we have too many colliders or collisions calculation in this project, the CPU can becomes overloaded. So to optimize this common problem in so many projects, we can reduce the fixed update frequency in the time settings using like simple colliders instead of complex meshes, and disable physics objects that are not close to the player, so we can reduce these calculations of physics in the CPU. In this part of the metrics, we have global illumination and lights. So another important point is global illumination. I see spikes related to dynamic lighting. If you can see here, this happens because real-time lights and shadows are constantly recalculated, which put a lot of demand on the CPU and the GPU. So the solution is very simple. It's just to use a baked light, that is recalculating lighting in textures called light maps. So this is much cheaper in terms of performance. So we can also reduce the number of real-time lights or shorten distance between shadows. so that can relieve stress on the CPU, also the GPU. And well, these are just the top 5 things that I saw on the project, because the project was really light for my computer, for all my setup, so I can run it, the games smoothly. So thank you for paying your attention in this video. I hope it helps. I hope you can apply these improvements and these advices in your projects on Unity. And of course, I hope I can help you, at least to understand how these metrics can be read. And we're gonna see each other to another video. So goodbye everyone.